Hello, in this video we're going to carry out a what's in my tray activity. You can see here we have our Gratnells tray. If I open the lid you can see that we have some BrightSparks for kids resources and components. The activity that we're going to do is we're going to investigate whether switching from traditional bulbs to LEDs really does save energy. So in our tray we have 4 cells and cell holders. We have a bulb and a bulb holder. We have a white LED or light emitting diode. We have a two-way switch, a multimeter, and we have 9 leads. So let's lift out our tray insert. Here's our Gratnells tray. Let's make our circuit. So we're going to use 4 cell and cell holders. You can see the circuit symbol here, and you can see we have a black negative terminal and a red positive terminal. It's important that we wire our cells in the correct way. So we're going to connect our cells, our 4 cell and cell holders, in series. First of all, we'll connect a lead to the black negative terminal of our first cell holder. Then we'll connect a lead to the red positive terminal of our first cell holder and connect it to the black negative terminal of our second cell holder. Then we'll connect a lead to the red positive terminal of our second cell holder and connect it to the black negative terminal of our third cell holder. And then I'll connect a lead to the red positive terminal of our third cell holder and connect it to the black negative terminal of our fourth cell holder here. One more lead. We'll connect to the red positive terminal here of our fourth cell holder, and now we're ready to introduce our other components to the circuit. We're going to use a two-way switch. You can see the circuit symbol here, and you can see that we have 1 terminal socket this side of the switch and 2 terminal sockets on that side of the switch. So this allows us to change the route, the current of the circuit. If I flick the switch up, it operates between this terminal and the top terminal. If I throw the switch down, it operates from this terminal to the bottom terminal of the switch. So we're going to connect the switch from the black negative terminal of our cell holder here to the first terminal on this side of our switch holder. Then we're going to connect our bulb. You can see the circuit symbol here. You can see that we have 2 yellow terminals, so that means that we can connect our bulb here in either way into the circuit. And then I also have a white LED, a white light emitting diode. You can see the circuit symbol here. This time you can see that we have a black negative terminal and a red positive terminal. And it's very important that we wire this LED in correctly, otherwise it won't operate. Okay. So if I connect the red lead to the red positive terminal of our white LED, and then I connect a lead from the black negative terminal of our white LED to our top terminal of our two-way switch, and then I'll connect a lead from the bottom terminal of our two-way switch to our bulb, and then a lead from the bulb to our white LED. You can see that now I've completed the circuit. You can see that our bulb has now lit. We can measure the output, the current used in our circuit, using a multimeter. Now, we're going to measure the current. So here on our multimeter, you can see a scale here marked amps DC. And we're going to use the 200 milliamp setting. You can see that we've got 3 sockets on our multimeter. One is marked COM, and we always put a lead into COM. And the other one is marked volts, ohms and milliamps. So we're going to use this socket. When you use an ammeter, which is what we're going to use our multimeter for, you always put it in series in our circuit. So what we're going to do, I'm going to disconnect the lead from the switch, so that I'm going to put our multimeter from the negative terminal of our cell here, and we're going to put that into the COM socket, and then I'm going to connect the next lead from the switch to the volts, ohms and milliamp socket. Okay, I'm going to switch our multimeter to the 200 milliamp setting, and you can see here that our bulb is now operating. We're using 4 cells in series, so that's 1.5 volts, 3 volts, 4.5 volts, 6 volts. So potentially we have a 6 volt supply. And if we look at our multimeter, we can see that we have a reading here of 79.5 milliamps. If I switch to the white LED, I have a reading of 4.7 milliamps. And what we can do, we can reduce our voltage supply to our components. So I'm going to switch off our multimeter. Now you can see that our light has gone out, and I'm going to remove the 4th cell and cell holder here. Take the lead away. I'm going to connect it back up. So now we are operating with 3 cells in series, so 1.5, 3 volts, 4.5 volts. So we should potentially have a 4.5 volt supply now to our circuit and our components. So if I switch our multimeter back on, I'm going to switch it initially to the conventional filament bulb, and now we have a reading of 69.1 milliamps. Now if I switch that, our two-way switch over, you can see that we have a white LED operating, and we now have a reading of 2.6 milliamps. So there's a huge difference between the conventional filament bulb and our white LED. If I switch our multimeter off again and I remove one more cell, we're going to remove a lead. I connect the circuit back up. So now we're operating our circuit with two cells in series, so 1.5 volts and another 1.5 volts, so that's potentially a 3 volt supply now to our circuit. If I switch our two-way switch so that the filament bulb operates first, I turn on our multimeter, I now have a reading of 56.3 milliamps. If I switch that to the white LED, so our white LED still operates, I now have a reading of 0.5 milliamps. If I flick back to the filament bulb, can you see that our bulb is slowly becoming dimmer, whereas our white LED still operates correctly? I'm going to remove one more cell and cell holder. So now we're down to just one 1.5 volt cell. I take this lead out. I connect it back to the circuit. So now our circuit is complete. I have our two-way switch ready for our filament bulb to come on. If I switch our multimeter to 200 milliamps, we're now operating our bulb. It's just about on. You can see there's a very slight glow from our bulb, and it's 39.4 milliamps. If I switch our two-way switch up towards our LED, this time our LED does not operate. We haven't got enough voltage or current through to our white LED for it to operate now. But in previous readings, it was very clear that the white LED, or white light emitting diode, was far more energy efficient compared to the filament bulb. So if you carry out your investigation, see what readings you manage to get from your circuit.